Okay, so I want to talk to you guys just a little bit more about the quadratic equations, and I know that we left off talking about completing the square. So the idea is that if we're given a quadratic equation and we want to try to solve it, the first thing we should always do is try to factor it, but sometimes it's pretty intense looking. So for example, I might have something like 4x squared plus 8x minus 9 equals 0. And in this case, when I go to solve something like this, the easiest thing to probably do would eventually be to use a formula that we'll talk about in a second. And then you could try to factor it, but it turns out that completing the square is going to be about the best way to handle this one currently. So the first thing I'm going to do is I'm going to, well, let's add 9 to both sides. So I have 4x squared plus 8x is equal to 9. And then I'm going to factor out a 4. So I have 4 times quantity x squared plus 2x is equal to 9. And then I'm going to look at the fact that I've got a 2 right here. I'm going to cut that 2 in half. And then I'm going to square it. And I end up getting 1. So to complete the square on the inside here, I'm going to add 1. But what I'm going to add to the right-hand side has to be 4. Because of that 4 on the outside of the quantity. Because really I've added 1 times 4, so I've added 4. Now I've got a perfect square, so it's 4 times quantity x plus 1 squared equals 13. I divide by 4 on both sides, I get x plus 1 squared equals 13 over 4. And then I can use the principle of square roots to say that x plus 1 is equal to square root of 13 over 4, or x plus 1 is equal to the negative square root of 13 over 4. And it turns out then that if I subtract 1 on both sides, x is equal to negative 1 plus root 13 over 4, or x is equal to negative 1 minus root 13 over 4. So those are my two solutions. So completing the square works out pretty nicely, and we could just continue to do that. It'll always work. You can always complete the square, but sometimes it might be that this 8 is not divisible by 4. Suppose I had 7x right there. Then in this step right here, instead of having x squared plus 2x, I'd have x squared plus 7 over 4x. Then you'd have to cut that thing in half and take the square of it and add that to complete the square, and that can be pretty nasty looking. But you can use this. You can complete every single square. You can take any quadratic equation and you can always complete the square. So if you can always do it, why do it every single time? Why not start out with just an arbitrary quadratic, ax squared plus bx plus c equals 0. Well, if you have something like this, we could play the same game. The same game is subtract c to start with. So we get ax squared plus bx equals negative c. Well, the next thing we do is we cut this number in half. Well, we factored out the a, so you pull out the a. If you pull an a out of b, really what you're going to get is plus b over a x is equal to negative c. Because now if I multiply this out, I get a times x squared plus a times b over ax. And a times b over a is just b. Great. So then I'm going to take that b over a, I'm going to cut it in half, so I'm going to multiply it by 1/2, and I'm going to square it. And so I'm going to get b over 2a squared, which is equal to b squared over 4a squared. And you're not going to have to do this every single time, but I'm showing it to you because it gives us something really neat at the very end. Okay, so what I get is I get a times complete the square, x squared, plus b over a x, plus b squared over 4a squared is equal to negative c. But I have to add what I just added, so I'm going to multiply the a times the b over 4a squared, and I end up getting b squared over 4a. If I multiply a times b squared over 4a squared, I get b squared over 4a. So this becomes a multiplied by x plus b over 2a squared is equal to negative c. Well, what if I multiply this guy by 4a over 4a? It's a fancy version of 1 and it allows me to get a common denominator. So this part right here would give me negative 4ac all over 4a plus, well, it's going to be plus the same thing as going to have a 4a on the bottom plus b squared. So I get something that looks like that. Now I'm going to divide by a. So when I divide by a, I can multiply by 1 over a. So it's going to give me an a squared on the bottom. So now I've got x plus b over 2a squared is equal to, divide by a, so I get negative 4ac plus b squared. Maybe I should kind of put this down underneath that. Negative 4ac plus b squared all over 4a. And then the principle of square roots tells me that the inside is equal to the square root of this or the negative square root of this. So I'm going to put that over here. So it tells me that x plus b over 2a is equal to plus or minus the square root of the negative 4ac plus b squared all over 4a. And then if I subtract b over 2a from both sides, I get x is equal to negative b over 2a plus or minus the square root of negative 4ac plus b squared over 4a. Now, what we know about square roots is that you can take the square root of the top, divide by the square root of the bottom. Square root of 4a squared, sorry, it's supposed to be 4a squared. A long time ago, it was a 4a squared on the bottom here. So the square root of 4a squared is 2a, and then that gives a common denominator with the negative b over 2a, and finally what you end up getting is you get x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And this is what we call the quadratic formula. In fact, you've probably heard of it before. So that is the quadratic formula. And really it comes from just completing the square for every single possible quadratic equation, which means it gives us the solution every single time. So if I want to use this formula any time I have any quadratic, I can just plug in the a, the b, and the c and figure out what x is equal to. So here's an example. Suppose I have 3x squared plus 2x minus 1 is equal to 0. Now again, I could try to factor it, and I might actually factor it into something decent. And if I can factor it quickly, go ahead and factor it. But if I can't factor it quickly, then identify the parts. I got a is equal to 3, b is equal to 2, and c is equal to negative 1. That means that x is equal to negative b, so negative 2, plus or minus the square root of b squared, so 2 squared, minus 4 times a, so 4 times 3, times c, which is negative 1. All over 2a, so all over 2 times 3. So that's equal to, x is equal to negative 2 plus or minus the square root of 4 minus 12 times negative 1, negative 12, so minus negative 12, all over 6. I'm going to carry that over here. Sorry, I've got such a small board. So x is equal to negative 2 plus or minus the square root of 4 minus negative 12 is 4 plus 12 is square root of 16 all over 6. So x is equal to negative 2 plus or minus square root of 16 is 4 all over 6. And there are two choices. There's a plus and there's a minus. So if you're looking at this, we could take the plus first. So x is equal to negative 2 plus 4 over 6. And x is equal to negative 2 minus 4 over 6. Now negative 2 plus 4 is 2 over 6, so x is equal to 2 over 6 or 1/3. And x is equal to negative 2 minus 4 over 6, so x is equal to negative 6 over 6 or negative 1. And so you get your answers. You can always use the quadratic formula. Now it turns out this one was actually factorable. So let's just double check and see if that works. 3 times negative 1 is equal to negative 3. And that means that I could rewrite this, and the factors of negative 3 that add to 2 are 3 and negative 1. So I could have rewritten this as 3x squared plus 3x minus 1, and then I could pull a 3x out and I get x plus 1, and pull a minus 1 out and I get x plus 1, and I get 3x minus 1 times x plus 1. Now if I set this equal to 0, I get x plus 1 equals 0 gives me x equal to negative 1. And I get 3x minus 1 equals 0 gives me x equal to 1/3. So those are the solutions, and you can always use the quadratic formula. So long story short, when you're looking at solving a quadratic equation, try to factor. If you can factor, great. And then go to the quadratic formula. You do not have to complete the square every time. You should practice it because it gives you a good feeling for the different types of algebraic operations you can do. But you can always just go straight to using the quadratic formula. It's something you're going to want to memorize because it's so beneficial. So it's x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And then it will always give you the answers.